Welcome to the peaceful space of sleep-friendly science, where tonight we'll gently drift through cosmic clouds to uncover the story behind our planet's vast, life-giving oceans. Have you ever gazed out at the deep blue and simply wondered, where did all of this water come from? Tonight, we explore this ancient cosmic puzzle. Was it a gift delivered by icy comets and asteroids, or did it well up from the very heart of the young Earth? Now, settle in, take a deep breath, and let the soft sounds guide you as we begin tonight's journey into the unknown. Section 1. A Primordial Canvas. Let us begin our journey together, not on the world you know, but in a time so ancient it almost defies imagination. Let your mind drift back, past all recorded history, past the first stirrings of life, back to the very infancy of our planet. Picture, if you will, the Earth not as a gentle blue marble suspended in the velvet dark, but as a glowing, furious sphere of fire and rock. This was a world without oceans, a world without a single drop of liquid water to soothe its burning skin. We call this time the Hadean Aeon, a name that whispers of an ancient mythological underworld. And it was, in every sense, a hellish landscape. Imagine standing on a surface that is not solid ground, but a roiling, churning ocean of magma. A sea of liquid stone, glowing with the fierce heat of its own creation, stretching to a horizon that is blurred and distorted by shimmering waves of heat. The air itself is thick, heavy, and unbreathable, a toxic cocktail of carbon dioxide, nitrogen, and sulfurous fumes belched from the planet's molten heart. The sky above is not the familiar, comforting blue of a summer's day. Instead, it is a bruised, oppressive ceiling of thick, dark clouds, perhaps tinged a malevolent orange or a deep, stormy purple by the incandescent glow of the world below. There is no sun to speak of, its light diffused and scattered by this primordial smog. And there is no moon as you know it, only a sky scarred by the constant, fiery trails of incoming debris. Our solar system in these early days was a far more chaotic and violent place. It was a cosmic construction site littered with the leftover building blocks of planets. And Earth was in the center of a cosmic shooting gallery. Day and night, if such concepts even had meaning, were marked by the relentless rain of asteroids and comets. Not as gentle shooting stars, but as mountain-sized projectiles striking the planet with unimaginable force. Each impact was an explosion that dwarfed any atomic weapon we could ever conceive, a cataclysm that would gouge massive, glowing craters into the magma ocean, sending up fountains of liquid rock that would arc across the sky like terrible, fiery plumes. This constant bombardment was part of Earth's very formation. Our world was built through a process called accretion, a slow and violent dance of gravity. Imagine tiny dust grains in a vast cloud of gas and dust, slowly, patiently, finding one another. They stick together, forming pebbles. The pebbles collide, forming rocks. The rocks crash together, forming boulders, then planetesimal small, infant planets. And with each collision, with each addition of mass, the gravitational pull grows stronger, attracting more and more material in an ever-accelerating cascade. Every single one of these impacts released a tremendous amount of energy in the form of heat. Think of it like a blacksmith's forge on a planetary scale. Every hammer blow of an asteroid strike heated the growing Earth, until the rock itself could no longer hold its solid form. It melted. The entire planet became this vast, globe-spanning ocean of magma we have been picturing. Any water that might have been present in those original building blocks, any ice trapped within those rocks, would have been instantly vaporized, turned to steam by the unimaginable heat, and likely blasted away into space by the force of the collisions. In the midst of this fiery youth, an even greater cataclysm occurred, a moment that would forever define our world. A rogue planet, a protoplanet roughly the size of Mars, which we now call Theia, on a collision course with our young Earth. The impact was not a glancing blow. It was a world-shattering event. Theia plunged into Earth, and the two bodies merged in a cosmic fusion of unimaginable violence. The energy released was so immense that it would have remelted the entire planet, from its surface to its very core. A significant portion of both planets was vaporized and thrown out into orbit, a glowing ring of debris that would, over time, coalesce to form our moon. Imagine the aftermath. An Earth hotter than before, its surface a seething cauldron. Any fledgling atmosphere it might have gathered would have been stripped away. Any water that might have begun to condense would have been boiled off and lost to the void. This was a planetary reset, a sterilization event on the grandest possible scale. So here lies the great paradox, the central mystery of our story tonight. As you lie there, feeling the gentle weight of your blanket, listening to the calm rhythm of your own breath, you are surrounded by water. It is in the air you exhale, it makes up the vast majority of your own body, and it covers over 70% of the planet you call home. The gentle lapping of waves on a distant shore, the quiet patter of rain on a window pane, the deep, silent mystery of the abyss, all of it seems so fundamental to our idea of Earth. Yet our planet was born in fire. It was forged in a crucible that should have left it a dry, barren, and lifeless husk, much like Mars or Venus appear today. It was a world seemingly destined to be without the one ingredient that, above all others, allows for the miracle of life as we know it. If the water wasn't here to begin with, if Earth was a primordial canvas, scorched and sterilized, then where did it come from? How did this glowing ember in the blackness of space transform into the cool, blue oasis we inhabit? The question hangs in the quiet of the room, a gentle invitation to wonder. The answer, it seems, was not to be found on this fiery stage. To find the source of Earth's oceans, we must lift our gaze from the molten surface of the young Earth and turn it outwards towards the cold, silent depths of the cosmos. The story of our water is not just a story about our planet, but a story about the entire solar system, written in the stars and delivered from the dark. Section 2, Water's Cosmic Birthplace. Let us leave the fiery, violent shore of the young Earth behind. Allow your awareness to expand, to lift away from that glowing sphere of magma and float out into the great, silent dark. We journey now, not just back in time, but outwards in space to a place far older and colder than our planet. We are searching for the true beginning of our story, the place where water itself was first conceived. Our destination is a vast, dark, and beautiful nebula, a giant molecular cloud. Do not picture an empty void. Instead, imagine a celestial cathedral light years across, a structure of such immense scale that our entire solar system would be but a grain of sand within its shadowed halls. It is not truly empty, but filled with a ghostly, tenuous mist of gas and dust. It is a cosmic nursery, a place where stars are waiting to be born. The temperature here is almost absolute zero, a profound, bone-deep cold that is essential for our story. In this stillness, in this incredible cold, the universe can perform its most delicate and patient chemistry. For it is here, in the dark womb of the galaxy, that the first ingredients of water begin their slow cosmic dance. First, there is hydrogen. Imagine it as the universe's firstborn child. Forged in the first few minutes after the Big Bang, hydrogen is the simplest and most abundant element of all. It is the fundamental stuff of the cosmos, a single proton and a single electron, a lonely wanderer that fills the vast spaces between the stars. It is ancient, primordial, and everywhere. It is the first half of our recipe. But hydrogen alone cannot make water. It needs a partner. It needs oxygen. And oxygen has a much more dramatic and fiery origin story. Oxygen was not born in the Big Bang. It is stardust in the most literal sense. To find its source, we must look to the great, incandescent stars that illuminated the early universe. These first-generation stars were giants, far more massive and brilliant than our own sun. Within their cores, they were colossal alchemical forges, immense furnaces of gravity and pressure. Here, they took the simple hydrogen and, through the process of nuclear fusion, crushed it into heavier elements. Hydrogen became helium, helium became carbon, and, in the final, furious stages of a massive star's life, carbon and helium fused to create oxygen. For millions of years, these stars burned, creating the precious, life-giving elements that the universe had lacked. But creating oxygen locked inside a star is not enough. To become part of our story, it had to be set free. And so, these massive stars would die in the most spectacular way imaginable, a supernova explosion. In a final, generous act, the star would blast its newly forged elements out into the galaxy. Imagine a wave of creation, a shockwave carrying the treasure of the star's life: carbon, nitrogen, silicon, and our coveted oxygen, seeding the vast, empty clouds with the building blocks of future worlds. So now, within our cold, dark nebula, the stage is set. We have the lonely, abundant hydrogen, and we have the precious, star-forged oxygen drifting together in the ghostly mist. But the space is so vast, the gas so thin, that the chances of an oxygen atom simply bumping into two hydrogen atoms at the right time are infinitesimally small. They need a place to meet, a cosmic meeting point, and that is the role of the dust. Scattered throughout this nebula are microscopic grains of carbon and silicate, themselves the remnants of long-dead stars. They are tiny, no bigger than particles of smoke, but they are crucial. They are the stage upon which water is born. Imagine one such dust grain, adrift in the immense cold. A wandering oxygen atom, heavier and slower than the hydrogen, gently collides with it and sticks to its frozen surface like a bit of frost on a cold window. The dust grain acts as an anchor in the void. Now, the grain is a target. The countless hydrogen atoms zipping through the cloud are far more likely to strike this grain than to find the lone oxygen atom in open space. A hydrogen atom collides, sticks, and finds the oxygen. A chemical bond forms, a quiet whisper of electromagnetism in the silent dark. They are now a hydroxyl radical, OH. The process is not yet complete. They wait. Time is of no consequence here. And then, another hydrogen atom strikes the grain, finds the hydroxyl, and the final bond is made. H2O. Water. A single molecule of water has been born, clinging to a speck of dust in the heart of a dark cloud billions of years before the Earth even existed. This is not a rare event. It is happening all at once on countless trillions of dust grains throughout the entire nebula. Each grain becomes a tiny seed, collecting a fragile mantle of water ice, molecule by molecule. Over millions of years, these specks of dust become coated in a delicate, frozen shell. The entire cloud, this vast cosmic nursery, becomes saturated with water ice. Not as a liquid, but as a fine, crystalline frost clinging to the very fabric of the cosmos. This is the cosmic inheritance of water. It is older than our sun. It is older than our planet. The water that fills our oceans, the water that makes up your body, the water you drank today, began its existence as frost on a speck of dust in a cold, dark cloud, light years away from here and billions of years ago. It is a profound link, a physical thread that connects you directly to the hearts of long-dead stars and the birth of the universe itself. This vast, water-rich cloud would not remain a gentle, drifting mist forever. Even in its immense size, the most patient and powerful force in the universe was at work: gravity. Ever so slowly, regions within the cloud that were just slightly denser than others began to pull more material toward them. A slow, gentle collapse began. A cosmic inhalation. Imagine a point at the heart of our story, a place where the dust and gas and ice are beginning to swirl, to fall inwards, to spin faster and faster, forming a great, flattened disk. At the center of the spinning disk, the pressure and temperature are rising. A protostar, our own infant sun, is beginning to glow, feeding on the material of its parent cloud. And all of that ancient, cosmic water, frozen onto trillions of dust grains, is being pulled in along with it, a vast reservoir of ice swirling around the nascent star, ready to become part of the new solar system that is about to be born. The story of our water is about to move to its next location, home. Section 3. The Solar System's Frost Line. Your awareness now hovers within this nascent solar system. The vast, cold cloud has collapsed into a great, spinning disk of gas and dust, a celestial potter's wheel that stretches for billions of miles. At its center, the dense knot of matter has ignited. This is our sun, a protostar, not yet the steady, golden star we know, but a young, turbulent, and fiercely hot furnace casting its first light and heat across its new domain. Everything is in motion. This disk, the solar nebula, is a cosmic river of material swirling around the central star. And within this river are all the ingredients we have discovered, the tiny grains of silicate and carbon dust, and clinging to so many of them, the precious, ancient mantles of water ice born in the interstellar dark. From this swirling platter of stardust and frost, a family of planets is about to be sculpted. But the young sun's fiery breath changes everything. Its radiation, its solar wind, pours outwards, bathing the inner parts of the disk in intense heat. This creates a gradient, a slow, steady change from scorching heat near the sun to the profound cold of the outer reaches. And this gradient creates a crucial, invisible boundary. A line is drawn in the fabric of the spinning nebula, a line that will dictate the fate of every world to come. Scientists call this boundary the frost line or the snow line. Think of it as a celestial shoreline. But instead of separating land from sea, it separates a realm of vapor from a realm of ice. Let us drift inwards, closer to the young sun, inside this cosmic snow line. Here, in the warm heartland of the forming solar system, it is simply too hot for that ancient water ice to survive. Imagine those delicate, frost-covered dust grains, spiraling inwards. As they cross the frost line, the sun's gaze falls upon them, and their icy mantles are burned away. The water doesn't disappear. It sublimates, turning directly from solid ice into a gas, a fleeting puff of water vapor that joins the thin, hot atmosphere of the inner nebula. The dust grains are left naked, stripped of their light, volatile coatings. All that remains here, in this inner kingdom, are the heavier, more resilient materials, the microscopic bits of rock and metal, silicates and iron. These are the only building blocks available. And so, the process of accretion, the slow gathering of matter, begins with a handicap. These rocky grains are less sticky than their icy counterparts. The process of building planets here is slow and the available material is limited. This is the region where Earth is being born. Picture it now, a tiny seed of a planet, a planetesimal, growing in the hot, dry zone of the solar nebula. It pulls in other rocky bodies through its growing gravity, a slow, violent accumulation of rock and metal. With every collision, its own heat increases. It is a world being forged in a cosmic kiln where liquid water cannot exist. Any water vapor in the surrounding gas is too hot and too light to be captured by the small world's fledgling gravity. It is simply blown away by the constant, energetic wind of the new sun. So, the 4 planets of the inner solar system, Mercury, Venus, Earth, and Mars, were all born of the same recipe. They are destined to be small, dense, and rocky. And they are destined to be born dry. The very location of Earth's birth, a place of warmth and proximity to its star, the very qualities that make it so habitable today, paradoxically ensured that it began its life without the one substance it would need for life. Now, let us drift outwards beyond that invisible frontier, across the frost line into the great, cold beyond. Here, the sun is a more distant, less threatening star. Its warmth is a gentle touch, not a searing blast. Here, it is cold enough for water ice to remain a solid. And that changes the story completely. The dust grains out here are still wearing their ancient, frosty coats. They are not just specks of rock, they are tiny, icy snowballs. Water ice in this cold realm is not a rare commodity, it is one of the most abundant building materials in the entire nebula, far more plentiful than rock and metal alone. And these icy grains are much stickier. When they gently bump into each other, they cling together more easily. Planet formation in the outer solar system is a different game entirely. It is life on easy mode. The planetesimals here grow fat and they grow fast, sweeping up the vast reserves of icy material. They become massive cores of rock and ice in a fraction of the time it takes for their rocky cousins to form in the inner system. And because they grow so massive so quickly, their gravity becomes immense. It is here, just beyond the frost line, that a king is born. A planet that would grow so large it would become a second gravitational anchor for the entire solar system. This is Jupiter. Its core of rock and ice swelled to many times the mass of the entire Earth, and its gravity became so powerful that it could now perform a new feat. It began to pull in the light, primordial gases of the nebula itself, hydrogen and helium. It cloaked itself in a colossal atmosphere, becoming the gas giant that has shaped the history of our cosmic neighborhood ever since. Jupiter's rise was a pivotal moment. Its enormous gravitational field acted like a gatekeeper, a great shepherd for the solar system. It likely prevented a fifth rocky planet from forming in what is now the asteroid belt, its gravity constantly stirring up the material there, keeping it from coalescing. Its influence was a wall, protecting the inner solar system from some of the chaos of the outer reaches. And beyond Jupiter, the same story unfolded on a slightly smaller scale, creating Saturn with its own majestic rings born of ice, and further out still, the ice giants, Uranus and Neptune, worlds whose very composition is dominated by the water, methane, and ammonia ices that were so plentiful in this cold domain. So picture this divided landscape. A solar system of two halves. On one side of the frost line, the inner realm, a few small, rocky, hot, and dry worlds huddled close to their parent star. On the other side of the frost line, the outer realm, a land of giants, built from a wealth of ice, growing huge and cold in the distant dark. And our Earth is on the wrong side of the tracks. It is a paradox written into the very architecture of our solar system. The water that would one day fill our oceans, that would carve canyons, that would nurture life, was present at the birth of the solar system in almost unimaginable quantities. But it was all kept at a distance, locked away in the cold storage of the outer solar system beyond that crucial frost line. Our planet was born thirsty in a place where the wells were dry. The question then becomes a matter of celestial import. How do you get the water from out there, in the cold realm of the giants, to in here, to the small, rocky world being forged in the sun's warmth? The cosmic stage is set. The pieces are in place. The water exists and the Earth exists. Now, the universe would need a delivery service. Section 4, Messengers from the Outer Dark. Our young Earth, as we have seen, was born into a dry and fiery existence. A rocky world formed inside the warm boundary of the frost line, a place where the life-giving water ice could not survive the sun's gaze. It was a parched planet in a parched corner of the solar system. The vast reservoirs of water, the inheritance of that ancient interstellar cloud, were locked away in the cold, outer reaches of the new solar system, far beyond the orbit of Mars. The story of our oceans, then, must be a story of migration. A story of delivery from the cold outer dark to the warm inner light. The Earth was a vessel waiting to be filled, and the universe, in its chaotic and creative fashion, had messengers ready for the journey. Let your mind travel to that outer realm, the cold kingdom beyond the frost line. Here, not all of the icy material was swept up into the giant planets. A vast multitude of smaller bodies remained, leftovers from the planetary construction project. These are the comets. Picture a comet not as the graceful, shining visitor we sometimes see in our night sky, but as it truly is in its home environment, a dark, unassuming object. A dirty snowball is the classic and quite accurate description. They are irregular lumps of rock and dust held together by a frozen matrix of water, carbon dioxide, methane, and ammonia ice. They are time capsules. Each one is a pristine, deep-frozen sample of the original solar nebula, preserving the chemical makeup of the cloud that birthed our sun and planets. For billions of years, most of them have drifted in the silent, frigid darkness of the Oort cloud or the Kuiper belt, the outermost frontiers of our solar system, their volatile ices remaining locked and stable in the profound cold. They are reservoirs of that ancient cosmic water. In the early, boisterous days of the solar system, the cosmic neighborhood was far less orderly. The newly formed giant planets, especially the immense Jupiter and Saturn, were not settled in their current, stable orbits. They migrated, their powerful gravitational fields shifting and resonating with one another. This grand tack, as some theories call it, was like a great, cosmic dance, and it stirred the entire solar system like a spoon in a cup. Imagine the effect this would have on the countless comets drifting in their distant orbits. The subtle gravitational nudge of a migrating Neptune, the powerful pull of a shifting Jupiter, these forces were enough to disrupt the fragile peace of the outer solar system. Orbits that had been stable for millions of years were suddenly destabilized. Comets were thrown from their paths like stones from a slingshot. Some were ejected from the solar system entirely, flung into the lonely dark of interstellar space. But others, a great many others, were sent careening inwards towards the sun. They began a long fall, a journey from the realm of ice into the realm of fire. As a comet crosses the frost line, the boundary we spoke of earlier, the sun's warmth begins to work its magic. The ices on its surface, which had been frozen solid for eons, begin to sublimate, turning directly into gas. This gas erupts from the comet's surface in jets and plumes, creating a vast, glowing atmosphere around the solid nucleus. This is the coma. The pressure of sunlight and the solar wind then pushes this gas and the dust it carries away from the sun, forming the iconic, beautiful tails that can stretch for millions of miles across the sky. The comet, once a dark and silent ice ball, is now a spectacular celestial messenger announcing its arrival with a brilliant display. And its destination is the inner solar system. Its path now intersects with the orbits of the small, rocky worlds, Mars, Venus, Mercury, and our own Earth. This leads us to the first great theory of where our water came from, the cometary delivery or late veneer hypothesis. The idea is simple and elegant. After the Earth had mostly formed, after its molten surface had begun to cool and solidify into a dark, basaltic crust, it was subjected to a period of intense bombardment by these water-rich messengers from the outer dark. Picture the scene. The Hadean Earth, still hot, but no longer a liquid ocean of magma. A dark, volcanic landscape under a thick, toxic sky. And in that sky, a constant procession of these fiery, ghostly apparitions. For millions of years, the Earth was pummeled by comets. Each impact was a cataclysmic event, an explosion that would have vaporized the comet and a vast area of the planet's crust. But with each fiery impact, a precious cargo was delivered. The water, which was the very substance of the comet, was flash vaporized into steam. A huge plume of superheated water vapor would have erupted into the primitive, thick atmosphere. Impact after impact, comet after comet, this process repeated itself. The atmosphere of the young Earth became increasingly saturated with water vapor, a planetary-scale steam room. The Earth at this time was still incredibly hot, far too hot for liquid water to exist on the surface. But the planet was cooling. Slowly, patiently, the heat from its formation and the constant bombardment was radiating away into space. As the surface temperature dropped, it would eventually cross a critical threshold, the point at which water could condense. Imagine the moment. The thick, steamy atmosphere reaches a saturation point. The temperature on the surface finally drops below the boiling point of water under that immense atmospheric pressure. And it begins to rain. Do not picture a gentle spring shower. This would have been a deluge of unimaginable proportions. A planet-wide flood falling from the sky. Rain that was hot, almost boiling. Rain that was acidic from the volcanic gases in the atmosphere. It would have fallen not for days, but for centuries, perhaps for thousands of years. It fell upon the hot, volcanic rock, turning to steam, rising back into the clouds, only to fall again. A colossal, planet-sized water cycle working to cool the crust. Slowly, the water began to win. It started to pool in the lowest-lying areas, the vast basins and craters left over from the bombardment. At first, these would have been boiling, churning lakes, but as the planet continued to cool, they grew larger, deeper, and calmer. Lakes became seas, and seas merged to become the first, primitive oceans. The comets, these beautiful messengers from the cold darkness, had delivered their gift. They had painted the barren, rocky canvas of the Earth with the vibrant blue of water. This theory is beautiful. It is poetic. But science is a story of constant questioning, of looking for finer and finer details. It is a detective story, and every theory must be checked against the evidence. The clues, it turns out, were hidden not in the grand scale of planetary collisions, but inside the water molecule itself. A tiny, chemical fingerprint that would either confirm the comet's role as our primary water bearers or point the investigation in a new direction entirely. Section 5. The isotopic fingerprint. The story of comets painting our barren world with water is a deeply romantic one. It feels right. It pictures the universe as a generous, if chaotic, artist delivering the gift of life from the frozen dark. We can almost see it, the fiery streaks in the Hadean sky, the steam-filled atmosphere, the first world-spanning rain. But science, in its gentle, persistent way, is a truth seeker. It honors a beautiful story, but it must always ask for proof. It is a detective and it must look for fingerprints. To find this proof, we must zoom in. Let your awareness shrink down past the scale of planets and oceans, past the scale of a single raindrop, and down into the very heart of a water molecule itself. The evidence, the crucial clue that would test our cometary theory, is hidden here in a detail so subtle it's almost unbelievable. A molecule of water, as you know, is a simple, elegant little family. One oxygen atom, large and substantial, joined by two light, nimble hydrogen atoms. H2O. It's a recipe known across the cosmos. But like any family, there are rare cousins, slight variations. The universe, in its infinite variety, has created more than one kind of hydrogen. The hydrogen we know, the most common kind, is as simple as it gets, a single proton in its nucleus. But very, very rarely, a hydrogen atom is born with a little extra something. It has the usual proton, but it also has a companion in its nucleus, a neutron. This addition doesn't change its charge. It still behaves like hydrogen. It will still happily bond with an oxygen atom to make water. But it is now heavier. It has more substance. This heavier version of hydrogen is called deuterium, and water made with it is often called heavy water. Think of it as a whisper of a difference. A silent chemical echo. In any collection of water, whether in a glass on your bedside table or in a distant comet, the vast majority of molecules will be made with regular, light hydrogen. But a tiny, specific fraction will be made with this heavier deuterium. The ratio of heavy water to regular water, the proportion of deuterium to hydrogen, or the D/H ratio, is a unique signature. It is a fingerprint. Every body in the solar system that contains water got its water from that original vast nebula. But the specific D/H ratio depends on the conditions where that water was formed and where it has been stored. Temperature, radiation, and time all play a part in subtly altering this ratio. Therefore, different regions of the solar nebula would have had slightly different water flavors. The water frozen in the frigid outer darkness of the Oort cloud would have a different chemical dialect than water that was formed closer in, near the frost line. Here, then, was the perfect test. If Earth's oceans were delivered by comets, the D/H ratio in our seawater should match the D/H ratio of the water locked away in those comets. The fingerprint on the gift should match the fingerprint of the messenger. For decades, this was just a tantalizing idea. Comets are small, fast, and very far away. How could we possibly taste their water to find this fingerprint? But with the dawn of the space age, we developed the tools. Powerful telescopes on Earth and in orbit could use spectroscopy, analyzing the specific light that shines through a comet's coma, to deduce its chemical makeup. And even more incredibly, we began to send robotic emissaries, spacecraft that could travel for years, rendezvous with a comet, and analyze its composition up close. The scientific community waited with bated breath. The first comets to be studied in this way were those from the Oort cloud, that vast, distant sphere of icy bodies at the very edge of the solar system. These were the classic, long-period comets, perfect candidates for the late Veneer theory. The results came in, and they were a surprise. The water in these comets was consistently, significantly heavier than the water on Earth. Their D/H ratio was 2 to 3 times higher than the ratio found in our oceans. The fingerprint did not match. It was as if the delivery service had brought the wrong package. This was a major blow to the simple, elegant theory of cometary delivery. If these comets were the primary source of our oceans, then our oceans should be much, much heavier. But they are not. This discovery sent a ripple of excitement and confusion through the scientific world. A beautiful theory was now in doubt. Did this mean comets delivered no water at all? That is rarely how science works. The universe is rarely so simple. Perhaps scientists thought we were looking at the wrong comets. The Oort cloud comets were born in the coldest, most distant parts of the nebula. What about comets from closer in? From the Kuiper belt, the icy disk of objects out beyond Neptune where Pluto resides. The European Space Agency's Rosetta mission, a marvel of human ingenuity, was sent to find out. It orbited a Kuiper belt comet, 67P/Churyumov-Gerasimenko, for years, studying it in unprecedented detail. It even sent a lander, Philae, to its surface. It sniffed the gases, tasted the ice. And again, the result was a surprise. Comet 67P's water was also far too heavy, its D/H ratio even higher than that of the Oort cloud comets. Another mismatch. The case was beginning to look bleak for the comets. More data from other comets painted a similar, complicated picture. The vast majority of them had water that was simply not the right flavor to be the main ingredient for Earth's oceans. There was, however, a fascinating exception. One comet, Hartley II, a member of the closer Kuiper belt family, was analyzed and its water was a near-perfect match for Earth's. A single, tantalizing piece of evidence that suggested at least some comets could have been the source. So where does this leave our beautiful messengers from the outer dark? It leaves them as part of the story, but not the whole story. They almost certainly contributed. The late, heavy bombardment was a real event, and it would be impossible for all those icy impacts to have delivered zero water. They added to the mix. They were likely a significant source for the atmosphere's volatile gases, and they sprinkled our world with a portion of its water. But they cannot have been the primary source. The fingerprint evidence is too strong. The bulk of our planet's life-giving blue cannot be accounted for by these spectacular, icy visitors alone. The detective, having ruled out the most obvious suspect, must now turn its attention elsewhere. If the water didn't come primarily from the comets of the cold, outer darkness, where did it come from? The search must move to a new class of suspect. A suspect that was born a little closer to home. Section 6. The Asteroid Answer. Let us not mourn the beautiful story of the comets just yet. Science is not about discarding stories, but about weaving them into a richer, more accurate tapestry. The comets, with their mismatched fingerprints, may not be the protagonists of our tale, but they remain a vital part of the ensemble. They were messengers, but not the primary ones. So our investigation, our gentle search for truth, must continue. We turn our gaze away from the deepest, coldest fringe of the solar system and look a little closer to home. Our destination now is the vast, quiet territory that lies between the orbits of Mars and Jupiter. This is the main asteroid belt. When you hear the word asteroid belt, you might picture a chaotic, dense field of tumbling rocks, a cosmic demolition derby like those seen in science fiction films. The reality is far more serene and far more vast. The space within the asteroid belt is so immense that if you were to stand on any given asteroid, you would likely not be able to see another one with your naked eye. It is a river of rubble, but a river so wide its contents are spread thin. This region is a fascinating archaeological site. It is the ruin of a planet that never was. The raw materials were there, but the immense, meddling gravity of nearby Jupiter kept them in a constant state of flux, stirring them up, preventing them from ever gathering together, from ever coalescing into a single, large world. So they remain today as they were billions of years ago, a collection of planetesimals, cosmic leftovers, a time capsule of the conditions in this specific neighborhood of the solar nebula. And this neighborhood is a very special place. It straddles the frost line. The inner part of the asteroid belt lies inside the warm boundary, and the asteroids here are much like the stuff Earth was made from, dry, rocky, and rich in metals. But the outer part of the asteroid belt, the region closer to Jupiter, lies just beyond that crucial line. Here, it was cold enough for water ice to have been a part of the original building blocks. So here we find a different kind of celestial body. These are not the dirty snowballs of the comet world, which are mostly ice. These are more like wet rocks. They are primarily silicate rock, but locked within their mineral structure, chemically bound to the clays and salts, is a significant amount of water. They are celestial canteens, rocky vessels carrying a hidden reservoir of that ancient water. The most famous of these water-rich asteroids belong to a class called carbonaceous chondrites. The name sounds complex, but it tells a beautiful story. Carbonaceous means they are rich in carbon, the fundamental element of life itself. And chondrites means they contain tiny, bead-like spheres of silicate material called chondrules, which are thought to be among the oldest solid objects in the solar system, droplets of molten rock from the very first moments of the nebula's existence. These asteroids are pristine relics, unchanged for 4.5 billion years. And now the crucial question. What about the fingerprint? What is the deuterium to hydrogen ratio in the water trapped within these rocky messengers? Once again, we needed a sample. But in this case, the universe provided a free delivery service. Occasionally, the gravitational dance of the solar system will nudge one of these asteroids out of its stable orbit. It falls towards the sun, and sometimes its path intersects with Earth. It streaks through our atmosphere as a meteor, and if it survives the fiery descent, it lands on the surface as a meteorite. These meteorites, fragments of carbonaceous chondrites, are gifts to science. They are pieces of the asteroid belt we can hold in our hands, study in our laboratories. We can gently heat them, releasing the ancient water that has been trapped inside their crystal structures since the dawn of the solar system. We can analyze that water. We can read its isotopic fingerprint. And here, the story takes a remarkable turn. Here, the detective finds the clue that cracks the case wide open. The D/H ratio in the water from these carbonaceous chondrites is a near-perfect match for the water in Earth's oceans. Let that sink in for a moment. The flavor of the water, the subtle chemical signature that was so wrong in the comets, was precisely right in these asteroids from the outer belt. The fingerprint on the evidence matched the suspect. It was a profound, thrilling discovery, a moment of deep clarity. The picture now becomes much sharper. The story reassembles itself with a new protagonist. After the Earth formed, dry and hot, and after the great collision that created the Moon, the same gravitational chaos that unsettled the comets also stirred the asteroid belt. The migrating giant planets, Jupiter and Saturn, sent gravitational waves rippling through this region. They flung these water-rich asteroids from the outer belt inwards, showering the entire inner solar system. This was the true late veneer. A bombardment not just of icy comets, but of these dark, rocky, waterlogged asteroids. Each impact delivered its cargo. A rocky body, perhaps a few miles across, would strike the young Earth, and the heat of the impact would have instantly vaporized the water that was chemically bound within its minerals. Impact after impact, a steady, relentless delivery over millions of years. Once again, this water vapor filled the primitive atmosphere. And as the planet cooled, that great, centuries-long rain would have fallen, not from cometary steam, but from asteroid steam. The water that began to pool in the craters that formed the first lakes and seas had a chemical signature that was born not in the deep freeze of the outer dark, but in the cooler, gentler region just beyond the frost line. This theory has a satisfying logic. It solves the location paradox. Earth didn't need water to be shipped from the other side of the solar system. There was a vast reservoir right next door. It solves the chemical paradox. The composition of these asteroids, less volatile than comets, is a much better match for the overall composition of Earth's crust and mantle. And most importantly, it solves the isotopic paradox. The fingerprint fits. This is now the leading theory for the origin of the majority of Earth's water. A gift from our rocky neighbors, the failed planet that became the wellspring of our own world's life. But in the quiet, gentle way of science, a single answer is rarely the final word. The universe is a complex and subtle place, full of overlapping stories. While this external delivery from the asteroid belt is a powerful and well-supported explanation, another question began to trouble the minds of scientists. Was it possible that Earth wasn't born completely dry after all? Is it possible that some water, an original inheritance, was here from the very beginning, hidden deep within the planet, waiting for a chance to escape? The investigation was not over. We had looked outwards for the answer, to the comets and the asteroids. Now it was time to look inwards. Section 7. Water from Within. For a long time, the story of our oceans was told as a tale of heavenly delivery. A narrative of comets and asteroids arriving as celestial saviors, quenching the thirst of a planet born of fire and dust. This late veneer theory, with asteroids as the primary messengers, is a powerful and well-supported chapter of our planet's biography. It neatly explains the chemical fingerprints we have found. It feels complete. But let your mind rest on a gentle counter-idea, a quiet what if. What if the Earth was not a completely empty vessel waiting to be filled? What if some of its life-giving water was not a gift from the outside but an inheritance from within? What if our planet had a secret, hidden reservoir tucked away during its violent birth, a treasure buried deep beneath the surface? This is the basis of the second major theory, a story not of external delivery but of internal origin. To explore this, we must once again travel back to the very beginning, to the swirling disk of the solar nebula. We established that the Earth formed inside the frost line, in the warm zone where water ice could not exist as a solid on the surface of dust grains. This is why we assumed our planet was born dry. But perhaps that assumption was too simple. The solar nebula was not a perfectly neat and orderly place. It was turbulent and messy. The frost line itself was not likely a sharp, static boundary, but a fluctuating, blurry frontier that moved as the young sun's energy output flared and dimmed. Picture those icy dust grains, the ones from beyond the frost line, being caught in eddies and currents within the nebula. It's plausible that some of these water-rich grains, our wet rocks, in miniature, were pulled inwards, crossing the line and getting mixed into the material that was accreting to form the Earth. They would have been a minority, a sprinkling of wet ingredients into a mostly dry recipe, but perhaps not an insignificant one. More importantly, water doesn't only exist as ice. It can also be trapped in a more subtle way. Imagine a microscopic grain of silicate dust, one of the primary building blocks of the Earth. Even inside the frost line, as this grain is forming, it can chemically adsorb water molecules onto its surface. Not as a thick mantle of ice, but as a single, tenacious layer of H2O molecules clinging directly to the mineral itself through weak electrical forces. It's not frozen water, but hydrated silicate. The grain is not wet, but it contains the ingredients for water, locked into its very structure. Now, picture the formation of the Earth from these building blocks. A slow, violent dance of accretion. Millions of these tiny, hydrated dust grains and small, water-rich planetesimals come together. With each collision, the growing proto-Earth gets hotter. But unlike a comet impact on a fully formed planet, this process is more like baking a cake. The water is an ingredient mixed into the dough from the very start. As the planetesimal grows larger, its own gravity increases, and the heat from collisions and radioactive decay begins to melt its interior, creating that global magma ocean we envisioned earlier. Now, what happens to that trapped water? The water adsorbed onto the dust grains? It does not simply boil away into space. The growing planet now has enough gravity to hold onto it. Instead, the water is driven into the rock itself. Under the immense pressure and heat of the planet's interior, this water is incorporated directly into the crystal structure of the minerals forming there. This is a key concept. Water doesn't just have to be a liquid or ice or steam. At the pressures and temperatures deep inside the Earth, it can exist as a supercritical fluid behaving like both a liquid and a gas. Or, even more profoundly, it can be broken down with its hydrogen and oxygen atoms becoming an integral part of the minerals themselves. Imagine a crystal of a mineral like ringwoodite or wadsleyite, which make up a huge portion of the Earth's mantle, the vast layer between the crust and the core. These minerals are like geological sponges. Their crystal lattice has spaces that can trap and hold H2O molecules, not as liquid water, but as hydroxyl OH groups chemically bound to the silicate. So, the theory of internal origin paints a new picture of the young Earth. It was not a perfectly dry rock. It was a planet that, from its very inception, swallowed a significant amount of its own water. It baked its water into its own mantle. The global magma ocean of the Hadean Aeon was not anhydrous. It was a seething, molten rock soup that had a significant amount of water dissolved within it, just as sugar can be dissolved in hot tea. This theory presents a stunning possibility. It suggests that deep beneath our feet, even today, there exists a vast reservoir of water. Not a subterranean ocean of liquid as you might imagine from a Jules Verne novel, but a hydrated mantle. A damp interior where the minerals themselves are saturated with the ingredients of water. Scientists, through studying the way seismic waves from earthquakes travel through the earth, have found evidence for this. In a region called the transition zone, between 410 and 660 kilometers deep, seismic waves slow down in a way that suggests the presence of these water-rich minerals like ringwoodite. The estimates are staggering. Some scientists believe that the amount of water chemically locked away in the Earth's mantle could be equivalent to several times the volume of all the oceans on the surface combined. Our planet may hold more water in its hidden depths than in all the blue seas we see from space. This changes our perspective entirely. The Earth is not just a rocky vessel that was filled by an external source. It is a self-contained system, a world that was born with its own life-giving water held in reserve, locked away in a mineralogical vault deep within its fiery heart. The question then is no longer just where did the water come from, but if it was trapped inside, how did it get out? If the planet swallowed its oceans at birth, what process could have compelled it to release them? How do you coax the water out of the rock and bring it to the surface to form the oceans, lakes, and rivers we know? The answer lies in the planet's own fiery breath. It lies in the slow, patient, and powerful process that shaped the surface of our world from the very beginning. The stage was set for a great exhalation, a planetary-scale release of pressure that would bring the hidden water from the deep mantle to the surface, transforming the world from the inside out. Section 8. The planet's first breath. Our journey has led us deep into the heart of the Earth to a theory that is both profound and intimate. The idea that our planet was not an empty vessel but was born with its own vast inheritance of water locked away in a crystalline vault miles beneath its surface. We left ourselves with a gentle, pressing question: if the water was inside, how did it ever get out? A treasure is only useful if it can be brought into the light. The answer is a story of planetary respiration, a story of the Earth's first mighty breath. Let us return to that Hadean world, but with this new knowledge. The surface is beginning to cool. The global ocean of magma is starting to skim over, forming a fragile, dark crust of basaltic rock. This crust is a lid, thin and brittle, covering a world that is still furiously hot and dynamic within. Beneath this lid, in the planet's mantle, the great, slow engine of convection is churning. Imagine the Earth's mantle not as solid, static rock, but as a fluid of unimaginable thickness and patience, moving on timescales of millions of years. It is a pot of cosmic stew, slowly bubbling. And within this stew are the water-rich minerals we discovered, the geological sponges like ringwoodite and wadsleyite, carrying their precious, hidden cargo of H2O. In certain places, great plumes of this mantle material, hotter than their surroundings, begin to rise. Think of them as slow-motion bubbles in a colossal lava lamp ascending from the depths over eons. As one of these plumes of hydrated mantle rock rises towards the cooling crust, it experiences a dramatic change. The pressure begins to drop. This is the key that unlocks the vault. Think of a bottle of sparkling water. While the cap is on, the pressure inside is high and the carbon dioxide gas remains invisibly dissolved in the liquid. But when you twist the cap, the pressure is released and the gas fizzes out of solution, forming bubbles. The same principle on a titanic and slow-motion scale applies here. As the water-rich minerals ascend, the immense weight of the rock above them lessens. The pressure that was forcing their crystal structures to hold onto those water molecules is reduced. The minerals become unstable. They can no longer contain their captive. They begin to sweat. On a molecular level, the water is released from its crystalline prison. It is forced out of the mineral structure, transforming back into a distinct fluid. Under these conditions, it's a supercritical fluid, a strange state of matter that flows like a gas but dissolves things like a liquid, and it is incredibly hot. This released water now infuses the surrounding molten rock, the magma. And water has a dramatic effect on magma. It lowers its melting point, making it more fluid, and it makes it far more buoyant. This wet, buoyant magma now has an urgent desire to rise even faster. It seeks out weaknesses in the new crust above fissures, cracks, thin spots. And so the planet begins to exhale. This was the dawn of volcanism on Earth. Do not picture the majestic, cone-shaped volcanoes we know today. In these early times, the crust was a fractured mosaic. The volcanism would have been immense, planet-spanning fissure eruptions. Great cracks in the Earth's skin, miles long, would have opened up, and from them would pour not just rivers of lava, but a colossal, sustained eruption of gas. This is the process of outgassing. The planet is releasing its primordial, trapped atmosphere. And what was in this planetary exhalation? A thick, heavy cocktail of gases from the interior. There was carbon dioxide, nitrogen, sulfur compounds like hydrogen sulfide, and, most importantly for our story, unimaginable quantities of water vapor. It was not a gentle sigh. It was a roar. A constant, furious venting of superheated steam from the planet's fiery lungs, a process that would continue for hundreds of millions of years. Every volcanic eruption was a conduit, a chimney connecting the deep, hydrated mantle to the surface. With every plume of ash and river of lava, the Earth was steadily pumping its hidden water reserves out of its interior and into the sky. The atmosphere grew thicker, denser, and increasingly saturated with this homegrown water vapor. It joined any steam that might have been contributed by the impacts of asteroids and comets, creating a truly immense greenhouse effect, trapping heat and enveloping the world in a thick, cloudy blanket. Now, our scene is set for a familiar event, but one with a new origin. The planet continues its slow, patient cooling. The surface temperature, despite the thick atmosphere, gradually drops. It eventually reaches that critical threshold, that magical point where the pressure and temperature are just right for condensation to begin. And so the great rain falls. But this time in our telling, it is a homecoming. The water that now begins to fall from the sky is not an alien substance delivered from the stars. It is the Earth's own water returning to itself. It is the planet's lifeblood, once sequestered in its heart, now liberated and returning to grace its surface. For millennia, this hot, acidic rain would have fallen, a deluge born from the planet's own breath. It fell on the new volcanic rock, cooling it, shaping it. It ran in rivulets and streams, carving the first, tentative channels into the landscape. It pooled in the great basins and impact craters, forming vast, hot, turbulent lakes. These lakes grew, merged, and deepened. The planetary-scale water cycle, the great engine of our climate, had begun. Water that fell would eventually evaporate from the warm surface, rise to form clouds, and fall again, in a continuous cleansing, cooling process. Slowly, steadily, the Earth was clothing itself in its own oceans, oceans drawn up from its own deep well. This theory of internal origin is profoundly satisfying. It suggests a planet that was not a passive recipient, but an active participant in its own creation story. A world that held the key to its own habitability deep within itself, and through its own dynamic, fiery processes brought that potential to life. It frames the oceans not as a late addition, but as a fundamental expression of the planet's very being. But science rarely settles for a single, simple answer when reality is often a beautiful, complex blend. We now have two powerful, well-supported stories. One of external delivery of water-rich asteroids arriving from just beyond the frost line, and one of an internal source of a planet born with its own water, breathing it out through volcanoes. The fingerprints in the asteroid water match our oceans perfectly. The evidence for a hydrated mantle is compelling. Which story is true? Do we have to choose? Perhaps the real magic lies not in choosing one, but in understanding how they might have worked together. Section 9, A Tale of Two Sources. The Great Collaboration. Our search for the origin of Earth's water has led us down two beautiful branching paths. One path took us outwards to the dusty, rubble-strewn river of the asteroid belt, where rocky messengers carrying a precious cargo of water were nudged from their orbits to fall upon our nascent world. The other path took us deep inwards into the fiery heart of the young Earth itself, revealing a planet that had swallowed its own water at birth, holding it captive in a crystalline, geological vault. It may feel as though we must now choose, as if we are standing at a fork in the road, where one path must be right and the other wrong. But the universe and the story of our planet is rarely a matter of such simple choices. The truth, in all its gentle complexity, is not a fork in the road, but the place where two rivers meet. The story of our water is not a story of either/or. It is a grand and resonant story of both/and. It is a tale of a great and vital collaboration between the heavens and the earth. Let us try to picture this grand synthesis. Let your mind become a theater for the first billion years of our planet's life. The Hadeanian is in full swing. The great collision that formed the moon is over, and a dark, fragile crust is beginning to form on the surface of the magma ocean. The air is thick, hot, and utterly alien. Now let the bombardment begin. This is the era astronomers call the late heavy bombardment. The gravitational stirring of the giant planets has turned the inner solar system into a cosmic shooting gallery. From above, the first contribution arrives. A steady, relentless rain of carbonaceous chondrites, the water-rich asteroids from the outer belt, falls upon the Earth. We are witnessing the external delivery in real time. Each impact is a flash of incredible energy, a momentary scar on the cooling crust, and a puff of released steam that billows into the thick, primitive atmosphere. This is the top-down delivery, a gift from our solar system neighborhood. But at the very same time, something else is happening. The Earth is not a passive target. It is a living, dynamic world. Beneath that bombarded crust, the planet's internal engine is churning. The great, slow convection of the mantle has begun. Plumes of hot, hydrated rock are rising from the depths. As they ascend, the pressure drops, and they begin to sweat out their ancient, trapped water. Volcanoes, great fissures in the thin crust, begin to tear open, and the planet exhales. This is the internal origin story in action. A constant, powerful venting of steam from the planet's own lungs joins the steam from the asteroid impacts in the sky above. This is the bottom-up delivery, a gift from the planet to itself. These two processes were not separate, they were intimately connected, a feedback loop of creation. The constant barrage of asteroids would have kept the young crust thin, fractured, and hot. This, in turn, would have made it even easier for the internal pressure to find release, enhancing the volcanic outgassing. The impacts from above helped to open the doors for the water from below. It was a partnership of violence and necessity. And what of the chemical fingerprint, the deuterium-to-hydrogen ratio that so perfectly matched the asteroids? This is where the story becomes truly elegant. The leading theory is that the water trapped inside the Earth's mantle from the very beginning came from the same source material as the asteroids that arrived later. The planet was built from planetesimals that were, themselves, very similar to carbonaceous chondrites. The Earth essentially accreted from the same wet rock material that would later bombard it. So, the water that was baked into the mantle during formation, and the water that was delivered later as a veneer, both carried the same isotopic signature. They had the same chemical dialect because they came from the same region of the solar nebula. The fingerprint doesn't point to one source over the other. It points to a single, consistent source region for all of the water, delivered through two different mechanisms at two different times. It is a stunningly beautiful piece of unification. Now picture the atmosphere. It is swelling with water vapor from this dual source. It is a planetary-scale steam bath, a mix of cosmic and terrestrial water, indistinguishable from one another, blended into a single, thick blanket. And beneath this blanket, the planet continues its patient, slow-motion cooling. Eventually, the moment comes. The surface cools enough. The atmosphere is saturated. The first drop of rain forms, and then a trillion, and then a deluge that will last for millennia. And as this rain falls, what is it? It is a perfect blend. It is the water of the cosmos and the water of the Earth's core, united at last. It is a homecoming and a new arrival, all in the same drop. This rain, hot and acidic, falls upon a landscape of fresh volcanic rock and the pulverized dust of countless asteroid impacts. It is a chemically potent brew. As it flows over the surface, it begins to dissolve minerals, to react with the rock, to form the first clays. It is not just water. It is a solvent, a medium, an agent of change. It is beginning to create a new kind of surface chemistry, a new kind of world. The great rain fills the basins. The oceans are born. Over hundreds of millions of years, this process would find a balance. The heavy bombardment from space would taper off as the solar system swept itself clean. The initial, furious outgassing from the planet's interior would slow down, maturing into the more measured volcanism associated with plate tectonics, a cycle that continues to this day, with water being carried down into the mantle at subduction zones and released at mid-ocean ridges and volcanoes. The planet is still breathing, a slow and steady respiration. So the oceans we have today are a testament to this grand collaboration. They are a blended inheritance. They are the legacy of a chaotic sky and a fiery heart working in concert. We have arrived. We have filled the canvas. The world is no longer black and red, but a deep and promising blue. The stage is set. The cradle has been built. The water is here. And with its arrival, the quiet, silent potential for something entirely new, something wondrous and alive, could finally begin to stir. Section 10, Our Blue Inheritance. The gift of an unlikely planet. So we arrive at the shore of the present moment, carried on this long, slow current of time. Let your awareness rest here, in this place of quiet understanding. The journey is complete. The mystery of the water has found its answer, not in a single, simple truth, but in a rich and layered story of cosmic collaboration. The water that fills our oceans, the water that paints our world blue, is a blended inheritance. It is a gift from the heavens and a gift from the Earth's own heart, a legacy written in the stars and forged in the planet's core. Feel the weight and wonder of that journey. Imagine a single drop of water, its hydrogen atoms, forged in the first moments of the Big Bang. Its oxygen atom, the last fiery breath of a long-dead, giant star. They found each other as frost on a speck of stardust, drifting in a vast, cold interstellar cloud, long before our sun was even a glimmer. This frosted dust was pulled into the great, spinning disk that would become our solar system. Some of it was baked directly into the rocky planetesimals that would build our Earth, a secret reservoir of water swallowed during the planet's violent birth and locked away deep in the crystalline structure of the mantle. The rest remained in the colder regions just beyond the frost line, forming the water-rich asteroids that would orbit in silence for millions of years. Then the great dance of the giants began. Jupiter and Saturn, in their majestic migration, stirred the solar system. Their gravity was the catalyst, the force that brought the two sources together. It flung the water-rich asteroids from their peaceful orbits, sending them on a collision course with the young, hot Earth. This was the delivery from without. At the same time, the Earth's own internal engine was churning, bringing its hidden, captive water up from the mantle through the fiery conduits of volcanoes. This was the release from within. The sky filled with steam from this dual parentage, and the great, world-cooling, ocean-forming rain began to fall. A rain that was both a homecoming and a new arrival. The oceans were born, a perfect blend of water from above and water from below, both sharing the same ancient chemical fingerprint, a testament to their common origin in the solar nebula. And here is where the story pivots from geology to biology, from the creation of an environment to the beginning of life itself. That water, falling as a hot, acidic rain on a world of fresh volcanic rock and cosmic dust, was not just water. It was a reactive chemical soup. It dissolved minerals, It carried elements. It pulled in volcanic vents on the seafloor, creating hydrothermal systems, places where hot, chemical-rich water from the Earth's interior mixed with the cooler ocean water. Many scientists now believe that in these dark, energy-rich environments, at the boundary between hot rock and cold water, the first sparks of life may have ignited. The water was not just a passive stage for life, it was an active ingredient. It was the medium, the solvent, the cradle where simple inorganic molecules could meet, react, and take the first, tentative steps toward complex organic chemistry. Life did not simply happen in water. In many ways, life is a clever and elaborate way of organizing water. Your own body is a testament to this story. You are a walking ocean. The salty tang of your tears and your blood is a faint, chemical echo of the primordial seas. You are over 60% water, a personal reservoir carrying on the legacy of that ancient rain. Every cell in your body is a tiny, self-contained bag of water where the intricate chemistry of life unfolds, a microcosm of the planet's own story. To gaze upon the ocean is to look into a mirror of our own origins. To see the waves crash upon the shore is to witness a rhythm that is billions of years old. The water cycle, the evaporation from the sea, the formation of clouds, the falling rainies, the planet's circulatory system, a constant reminder of the connection between the sky, the land, and the sea. It is the same water, recycled over and over, that fell in that first Hadean deluge, that flowed in the veins of dinosaurs, that has nourished every living thing that has ever called this planet home. The story of our water is a profound lesson in perspective. It tells us that our world is the result of a series of fortunate accidents, a beautiful sequence of cosmic and planetary events that could have easily gone another way. If Jupiter had not migrated, if the asteroids had not been perturbed, if the Earth had not trapped water in its mantle, our home might be as dry as Mars or as hellish as Venus. We live on an exquisitely rare and unlikely planet. Our blue world is not a given. It is a gift delivered from the stars, exhaled from the stone, and tenderly nurtured over billions of years. It is an inheritance of almost unimaginable antiquity and value. And so, our journey tonight comes to a gentle close. We have traveled from the hearts of dying stars to the molten core of our own world, all to understand the simple miracle of a glass of water. As you now let your mind settle, feel that connection. Feel the ancient stardust and the planetary fire that conspired to create the gentle blue world that holds you now. Let the deep, quiet rhythm of the oceans be the rhythm of your own restful breathing. Your story is written in water, and it is time now to drift peacefully on its currents into the deep and tranquil ocean of sleep. Good night.